Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. And what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but they will apply a lot of the same principles apply over in the UK as well. Now, if you do have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring live chat. If you're watching this after the premiere, then just feel free to leave a comment underneath the video and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on's diagnostic technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru. So I worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bed. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. Tonight's topic is the power of experience-based information. Now, information is key nowadays, I think. I always say wrenches don't fix cars nowadays. Information fixes cars. The actual wrench part, really not all that large a percentage of your time when you're actually fixing a car. A lot of the times actually looking up the information, seeing what needs to be done and what other people have done in their experience over time. So when asked, and I think this is pretty true because I'll ask this question anywhere I go, and pretty much any tech will agree that most of their diagnostic time is spent looking up information. Right? Sometimes you just have that one that's off the top of the head. You've seen it a million times. You know exactly what it's going to be. But the majority of the time, especially on a new problem, it's going to be spent looking up information. And that, of course, is going to decrease your efficiency. And we know everything should be all about efficiency there. So to speed up diagnosis, access to information must be easier than it currently is. Or maybe you don't know that there might be an easier way already there. So there's two different types of information when we're dealing with the automotive world. We can really just bring it into two buckets. So we have the OEM information, which of course is direct from the manufacturer. So that can be any of their repair information that they publish, any of their technical bulletins, any recalls, campaigns, any of that information would be considered direct from the manufacturer. Other information would be your real world information. So it's either information based on actual repair orders, repair order data, or based on a tech's experience out there in the world. There's many different places that can be gathered. So as far as that real world information, let's think about repair orders. So we would go take the repair orders. When this same year, make, model engine vehicles come in with this same problem, what has fixed this problem? And if you have a big enough stack of those, you might end up with some pretty good information. Or knowledge in your own brain. I've seen this car before, using the tech's knowledge from their own experience. For example, as I always say, I worked at Subaru for 8 years. And over that time, we figured out, if it's a early 2000s till about 2010 Subaru, any non-turbo Subaru, if it comes in with a P0325 knock sensor code, it's just going to get a knock sensor, because that's what the problem is. It just had terrible knock sensors back then, I guess, but it always fixed the problem and the car never came back. So we just figured out after a while that, hey, it's got a P0325, gets a knock sensor. Simple as that. Didn't even have to go through a trouble chart or anything. You just walk over to the parts counter and say, give me parts, give me a knock sensor. You knock it out in half an hour and you're done. But that is built on knowledge base from over time, learning that, hey, every single time that this problem happens, and it was pretty common back then, when this problem happened, this is what the problem is. All right, and there's tons of those examples out there. You could probably think of a bunch off the top of your head. Hey, when this particular thing happens with this particular vehicle that I see all the time, I know that I need to do this to fix it. Easy enough. And then the other examples, other technicians. So maybe not your knowledge base in your brain, but hey, maybe your buddy down the street, maybe your buddy 2 bays down has seen this problem before. Hey, what have you done when you've seen this car with this problem? So there's a bunch of different ways that we can get this real world information. Having it readily available to us is very helpful when it comes to trying to diagnose a problem, maybe a tricky problem, maybe a problem we've never seen before, maybe a problem we have seen before. So we're going to give you an example with a case study here. This is one of my favorite case studies because this just goes to show how powerful experience-based information can be in the real world. So it's a 2006 Mini Cooper S, and the symptoms are it's a lack of power and it's got an engine. Simple enough, right? So that's a supercharged Mini Cooper. So the code was, they scanned the codes, and the code that came up with a P1688 code. So an electronic throttle control motor monitor, electronic throttle control monitor, level 2-3 mass airflow calculation. So right off the top of my head, without doing any other research and just looking at the code definition, we would think maybe it's a problem with the electronic throttle control. It's got to drive by wire. Maybe it's a mass airflow problem. Maybe it's a problem in the air duct. So maybe we have a leak there or something like that, right? Just off the top of your head. But of course, we don't want to jump to conclusions. We want to do our research. As we said, we want to check out what have others done. What does the manufacturer even say in this case? So if we go into TSBs, the first thing up here on the top left-hand corner, now we're used to looking at Fast Track Intelligent Diagnostics. This is your first time here. This is our proprietary system that we use based on lots of real-world information to filter down the information that only you need for the problem at hand, and then filter out the rest that you don't need, so you don't have to worry about it. So in this case, there are 2 TSBs for this problem. First one is this DME fault P1688. So they say it's a Cooper S with the W11 engine, which would be this one. And they use that for a few years in there. And it says customer complains of lack of power and engine is in failsafe mode. Service engine soon light is illuminated in fault code P1688 electronic throttle control monitor is stored in DME. Fault can be caused by one of the following. I think I scroll down here a little bit. There we go. Fault can be caused by one of the following. Possible air leak in the induction system. MAP sensors are indicating implausible values, or a failure of the supercharger bypass valve. It's sticking. Okay. A couple of those were the ones right off the top of our head, right from that definition. But let's see. So failure of the bypass. So check the complete air intake system, including throttle body, supercharger, intercooler, and inlet manifold for air leaks. If no problem is found, verify both the manifold absolute pressure sensors show plausible values. If values are not plausible, refer to the MAP sensor test module. If values are plausible, replace the supercharger bypass valve and reprogram the computer. Okay, easy enough. So either I have leaks or I don't. And if I don't have leaks, I want to make sure the MAP sensor works or it doesn't. And then if it doesn't, I'm going to test the MAP sensor according to their test modules. So Mini and BMW, right, they use these test modules. It's not necessarily a written out book anymore. It's just they have these test procedures, test plans that they go through. And then it gives you a way to check it after the fact. So kind of beat the bag off the vehicle and make sure that it works. The other one says P1688 diagnostic hits. So in this one, customer complains lack of power, engine in failsafe mode, and it's got a P1688 code. And once again, it says possible failure of supercharger bypass valve. In this case, it says when performing the test module after fault P1688 is stored, in most cases, the test plan incorrectly directs the technician into replacement of the actual control module, the DME, which is the digital motor electronics, or the ECM in English. When diagnosing Cooper S with fault 1688, inspect proper operation of the bypass valve in the air intake system using a handheld vacuum pump, activate the bypass valve, and observe its operation. If it's sticking in any position, replace with a new part. So, what have we learned so far? Just by checking the TSBs. If you follow the test plan as laid out by Mini, BMW, what have you, you will replace the computer, and it's about a little shy of $1,400. Or if you follow the TSBs that they lay out for you, it'll be $116 for a bypass valve. Okay, fair enough. So some people might just go this far and just say, all right, that's what they tell me to do. That's what we're going to do. And maybe they'll be right. Maybe they won't. because we also have experience-based information that we can use here. In this case, this is just OEM information. And in my experience, and I think those of you who have worked in the field for any amount of time will agree that there is the real world and there is what happens in an engineering lab, right? So engineers write test plans and such. Real world mechanics actually fix the cars. So maybe there might be a discrepancy there in what happens in the real world. So if we go a little bit further, we go back to our landing page and we have our TSBs here, and it says either replace a computer or a bypass valve. Or in this case, this is our top repairs for this based on quite a few repairs. Number one by a mile is replace the harmonic balance. That's interesting. Replace the harmonic balancer 190 times over 200,000 miles this occurred. The peak was about 68, 69 of them or so in there at about 100,000 miles. Is a big peak there, and then it kind of drops off from there. Also, crankshaft bolt, so that would go hand in hand with that, I would say. Drive bell tensioner, yeah, while I'm in there, maybe might as well do that. Supercharger, well, that can be a pricey proposition if you replace that one by accident. And then the fuel filter, well, maybe they replaced it at the same time. Happens. But I would say that'd probably be a pretty good place to check, especially since it's easy. I can use these and I can use these in order to check. Eyes and ears. That's all I really need. Check that. And if I go down further, there's some more information that reinforces it. So the number one real world real fix based on real world repair orders says the customer states to check engine lights on, the vehicle lacks power and acceleration. Same complaint. Confirm the customer's complaint, found the vehicle lacked power and acceleration. Connected a scan tool, found P1688. At idle, backprobed the mass airflow sensor, monitored the sensor signal on a lab scope. The mass airflow sensor observed on a lab scope was within specifications. Performed a second road test of the vehicle, heard a slight metallic noise from the front of the vehicle, and smelled a burning rubber odor. Hoisted the vehicle, inspected the front of the vehicle, and noticed the crankshaft pulley had separated from the harmonic balancer. Crank pulley is integrated into the harmonic balancer and is replaced as an entire unit. The damaged crankshaft pulley caused the DME to miscalculate the vehicle's engine speed. Therefore, the DME miscalculated the engine load parameter and set the trouble code. So, in a nutshell, and I'm going to show a picture of this here in a minute, but the harmonic balancer, rubber in the middle, metal on the outside, metal on the inside, right? So if it separates, and you may have seen a separated harmonic balancer on other vehicles because it's fairly common because that rubber heats up and cools off and it's subject to a lot of stress. But on this vehicle, it is also running the supercharger. So if my engine is running at a certain RPM and there's no real connection to that belt, maybe it might slip and stick and move it at a certain amount of time, but that supercharger is definitely not spinning as fast as it needs to be spinning to pump the volume of air into the engine that it needs at that load. So in that case, I have a discrepancy in my airflow, right? The engine's turning at one speed, supercharger is not providing the airflow it needs, and the computer gets confused, just says, hey, it's a mass airflow mismatch, figure it out. Go down a little bit further to additional real fixes, and we can see we have another, there's the number one there, and then there's another one there where the one time we replaced the map sensor. So if we go in there, ran rough, found it, checked the map sensor, and it was below specifications. Okay, so that was a possible cause on the TSB, but in this case, not all that common. If we go to repair information, go into OEM information. In here, like I said, they have test plans, so we don't really have an OEM test procedure, so to speak, because it's kind of built in the scan tool, right? But we see related right there, crank balancer, pulley damper, 167 times there. So if you want to pull it up, you get TSBs, real fixes, top repairs, and causes and fixes. We're gonna look at the causes and fixes a little bit later when we go live. But that'll give you basically the same information that we already had in the intelligent diagnostics. So in this case, the OEM doesn't really give us a lot of information, but the fix is from experience. So there's a separated crank pulley harmonic balancer from a Mini Cooper with this engine. Same problem. It is apparently very common. I've talked to people out, doing classes and whatnot. They say, oh yeah, that happened to me like 3 times last year. So it's fairly common out there. So here's the center part that goes to crankshaft, of course, and then we have the rubber damper. And then along the, this kind of goes over the outside of that, right? So this would be like two pieces meshed together. So you can see where it's separated there. The rubber just came apart. And then, yeah, so I can't spin the supercharger at the right speed. We have a problem. Right. So that is just one of many examples that are out there in the real world. I'm sure you have plenty of examples on your own of things that you've experienced in your own life. But how we can bring this all together, and you may not be aware of how much of this information you could be able to access at any given time. If you have a Snap-on scan tool and you have current software in the tool, you have access to a lot more information than you may be aware of. So we want to talk about this. There are vast amounts of data that we have. We have a collection of over 2.25 billion repair orders. Billion. That is a really, really big number. And we've come to discover over the years that human beings, when it comes to once we get to billions, even millions, it's kind of hard to comprehend, but billions, you get really, really, it's out there. So I decided to do a little thought experiment. What would happen if we took those 2.25 billion repair orders and printed them out? And let's say they were really efficient at writing up these repair orders, and it was only 1 page per repair order. If I were to print those out on a standard 8.5 by 11 sheet of paper, and I laid them end to end, that length of paper would be 390,625 miles laid end to end. Now the moon, you know the moon, the thing that's in the sky, right? 238,900 miles away. The Earth's circumference is 24,901 miles at the equator. The moon's circumference is 6,786 miles. So, with this path of paper, we could go around the Earth 5 times, then go to the moon and go around the moon 4 times, plus a little bit more with all of that paper. That is a lot of paper. That is a lot of repair orders. That is a lot of information. So we have all of this information available to us at any given time. And of course, it's on any vehicle that would be worked on with our repair management system. So having that vast amounts of data, being able to parse that down and being able to access that, you can access it on the scan tool. You can also access it on the web. Did you know, even if you don't have access to ShopKey, that you still have access to SureTrack information on the web, not just on your tool, on the web? So you would go to, in order to log in, here, I'm going to walk you through all the steps here. So you would go to log in and you would go to shopkeypro.com. But if you log in, you can go to actually down here and go to create a new individual account. So you can create your account if you don't have one already, and we'll show you where to put the information. But if you just try to log in, it's not going to let you in. But you've arrived at this page because your SureTrack account is either expired or not associated correctly with the current qualifying product. So you need to have, and actually this is kind of out of date here. This needs to get updated. But if you have a Snap-on scan tool and you do an update, anytime you do an update, you will get a little code number. You get a little code number there, and you'll punch it in your account, and it gives you 6 months of access to SureTrack information on the web. So we go down here, it gives us a little bit more information, and it tells you how to associate your authorization key down here. Like I said, this kind of needs to be updated as well, but this will allow us to access this. It's really pretty much any of the scan tools that are currently able to be updated. You'd be able to access that. So it actually needs to get updated. I need to put in a ticket for that, but so it walks you through how to create an account, right? So you can do it with ProDemand, ShopKey, Sun Collision, and Snap-on scan tools with current software. Once you do that, we've seen this page a few times. So this is your account information on ShopKey and your Snap-on Cloud account, Altus Drive, what have you. Any of that information, there's an authorization key down here that gives you. Now you can't copy this one because I already used it anyways, but you would type in the authorization key here and it gives you 6 months of access. So I did this one back in February. So it gives you 6 months of access. You can go in, and when you do log in, you'll notice that it gives you a limited, one search limited, and a SureTrack community tab. Right. So if I go into the main page, I just loaded my vehicle, for example, you'll see you get access to TSBs, component tests. On this 2011 Subaru Forester 2.5, you'll see that based on analysis of 123,619 repairs. So that's out of those 2.25 billion repair orders, 123,619 were 2011 Subaru Forester non-turbos. And then it gives you the most commonly replaced components, codes, symptoms, and lookups. All available for you. Like I said, as long as you have your software up to date, you get a code and you can plug that in. Let's do a search for I think it was the number one code, right? Yeah, number one code is PO171. So if we do a search for that, you see we get TSBs, real fixes, top repairs, causes and fixes, guided component testing, component connectors, component locators, component operation tips, all that information available to us right there. Here's TSBs, 2 TSBs there. A wealth of real fixes from 363 down to, less than 11. I'm sure we can scroll down and probably get down to 1 or 2. We have our common repair procedures, or the common repairs graph that we see on the scan tool. It's also available here. This is the causes and fixes. This one's actually pretty cool because you can do code combinations. I'll show this live here in a minute. Guided component testing, right? So just like the component tests you would find on your tool, if you have a tool with guided component testing built in, these are the guided component tests available here. Just the only thing is it wouldn't set up the meter, of course. It's just going to show you the information, though. You also get the component connector views. You can get the component locator. Also, component operation tells you how it works. And then related tips. Here's a drive cycle tip. Here's a couple tips on PO171. And then back on the main page, we can go into TSBs, and you get your full list of TSBs, not just filtered out by search. And we can also go into component tests and go through each individual system, ABS, body electrical, what have you, whatever the vehicle has access to. So let's walk through that live and show you what that would look like on the tool. Now, in this case, we're mixing it up a little bit here too. So I always get, hey, you always show it on a Zeus or a Triton or an Apollo. Why don't you show it on a tool that doesn't have intelligent diagnostics? So here's what we're going to do. We got a Veris Edge right here, updated to 23.2. And we're just going to pop through it, right? So we'll go into the scanner, and we'll just go into our demonstration vehicle, as we do. Currently in demo mode. All right, so there we go. We can do our usual code scan that we would normally do. We can do a pre-scan, post-scan, or health scan. It's going to scan through the modules. Okay. Once it does that and it saves the system report, it's going to be very much like any other scan that we do. It's going to scan through all the modules. It's going to scan the OBD2 side as well. We got a PO300. We got a PO446. You'll see that the graph changes every time that we switch bit back and forth. Also on this tool, unique to this tool, the Veris Edge, is if I got something that's kind of, they got a lot of crossing back and forth in the middle there. Like these are fairly clear cut, but if I had a lot of stuff going on back, like these two down here, couldn't really tell what was going on there. I can actually click these on this tool and it'll turn them on and off. So I can see what's going on. Like that throttle body's kind of covering stuff. That fuel injector's kind of covering stuff, right? I can actually turn these lines on and off on this tool. So I thought that was kind of interesting and different. So we do have the commonly replaced parts graph based on the code. And once again, based on the repair orders. And in this case, we found 2,794 repairs of the O300. This demo path might be a little outdated, but if we go in to fix it though, we can go in there. And we can see, once again, we get our number one real fix. So there's our complaint cost correction based on the repair orders, and the graph stays. We have related tips on the top. That's going to be anything else that's related. We're going to have any real fixes, and it ranks it by number of confirmed fixes, right? 42 to 16. And then in this case, we can go into repair information. Now, on this tool right now, I'm logged in as my ShopKey account. So it's going to log me in, and it's going to bring me into ShopKey. So it's going to log me in, log the vehicle in, log the code. I just got to pick the couple of parameters there. And we'll see it pulls up my standard ShopKey information. I can go in under ignition coil, and you'll see I got 3, 6, 9, 12, 15 different cards that I can have access to. Anything from TSBs through parts and labor. All right, and that's all good stuff. That's if I have Shopkey or Mitchell. Now, if I don't have Shopkey or Mitchell, which is what we're talking about here, is if you just update your scan tool and you put in the code and you get 6 months access, I'm going to log out and I'm going to switch to my other account. And when I do that, I do have to reselect my vehicle. So 2016 Chevy Tahoe. Easy. Okay. Now you'll see it looks a little bit different here. So you see I got TSBs and I got component tests, but everything else is grayed out, right? So it's one search limited is what they call it. I still do have access, though, to commonly replaced components, common codes, common symptoms, and top lookups. So if I go back in here and look up that P0300 again, and then I go to my ignition coil again, you'll see I get 369. So I had 15. So there's 6 of them that I don't get access to just because of, that's the paid service of it. But the experience-based information, I get information to my TSBs. There's my filtered TSBs just for that problem. Real fixes, right? We get our complaint cause correction ranked. Top repairs, that's our graph. And also on the web version, you can turn these lines on and off as well. Causes and fixes, I said I would go in here too, because this one, I think this is one of the most underutilized features of both Shopkey, Mitchell, and SureTrack, because it's all like pulling from the same data, but it's code and code combination. So on the scan tool, we can only choose one code at a time because that's all we're working. But if I have multiple codes, the more information I can throw at a problem, the easier it is to drill down on what that actual solution might be. So in this case, PO300, yep, we get the whole laundry list. But these 3 codes, a 300 and a 50D, it narrows it down to 5 things. And if I have a 300, a 50D, and a 219A, more than likely it's fuel injector. 21 times that was the problem. Now, I'm not going to tell you, just go ahead and replace that because that's a really bad idea. But that's the first place I'll look, because if I get these 3 codes, what is the likelihood it's going to be something else? And if I have 4 codes and so on, it's the more information that we can throw at a problem, the more experience-based information, what really actually fixes this car in real life that we can throw at a problem, it's going to solve a problem easier. Right? So it's correlation. Right? It's way, way less likely that is not the solution if we throw all that information at it, right? So that's why I really like the causes and fixes, because it helps you filter that down. Because you can get a car in with 20 different codes. But if I get those 3 codes together, it may very well be that. Right? Good to know. Of course, guided component testing, we have that in there available. There's my cam sensor test right there. Go through it. It's got my known good patterns and my different tests that I can do. There's current ramp tests and so on and so forth. Now, these are available inside the tool as well, right? So if I just went into the guided component test on the tool, this gives me the advantage of being able to have the meter actually set itself for me too. So if I went in there, say go to the cam sensor and go into like a signature test, right? I can go in there, you can see a cam signal, you can see my new connector views that we just added in the latest update too, which is nice. And then we have a known good pattern down here, hit view meter. Of course, on the tool, it's going to automatically set the voltage range where it needs to be, automatically sets the time base where it needs to be. All this information is still available to me. If I see this down here, it's good. All right. Makes life a lot easier having that information readily available. If I go back to my repair information, though, we can see that that's all still available there. So this is available on, like I said, pretty much anything from a Solus on up, as long as you update your software, even if you don't have Shopkey. And for those of you in the UK, I don't believe you can still access this in the UK. I'm not sure. I'll actually have to check on that, because that might be a good little thing for you all. I'm not sure if you can access this from the UK. Might not be able to, just because of licensing or whatever. But definitely in the North America, you definitely can. So when you update your scan tool, if you update with your franchisee, you can just go in on your receipt. It'll give you a little code. And then on if you have so software subscription, you should get an email. That'll give you a code in there as well. And if you do it otherwise, you should still get an email, because any other option you have, you should have an email address registered with. If not, if none of those work, then you can always call tech support, but make sure that's your last resort, because you should be able to get it pretty much anywhere else with that. So hopefully you learned a little bit more about utilizing the repair information that's available to you. You may not have even known that it was available to you, included with your software update. So definitely check for that code if you haven't before, and then you can just add it to your Snap-on account. Like I said, you get 6 months of access. Just go to shopkeepro.com, type in whatever your Snap-on login is, and it'll get you to the information. And with that, that is our time here today. So make sure you tune in for new diagnostic content every week. We will be premiering a new video every Wednesday at 7 p.m. UK time. So make sure you check it out on the YouTube channel. If you're watching, well, of course, you would be watching this on YouTube, but make sure you subscribe, thumbs up, ring the little notification bell so you know anytime we post new content. And it's youtube.com/SnapOnDiagnosticsUK. With that, time for questions. If you have any questions, just feel free. Once again, if you're watching this on a premiere, just leave it in the live chat and we'll answer those. Otherwise, leave a comment under the video and we will get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've given you today. Hopefully we'll see you next week. Hopefully you can watch and see you on any of our other videos. Have a good week. Have a good night and take care.